Again, hello and welcome to our today's webinar. Uh, with our time today, I will be providing us with the demo of PS Tool in action that is dedicated to our exciting recent news, the release of self-serve access to PS Tool for Android apps. I'll dive into this in just a bit. In the meanwhile, we have 30 minutes booked for this demo session. That includes time reserved for Q&A at the very end of this session. So if you have any questions at all, feel free to type them down here in Zoom chat or in live stream chat on LinkedIn platform, or just shoot me a DM in Zoom and we'll try to address all of your questions at the end of this session. Now, before we start, a couple words about myself. My name is Anastasia Matveyeva. I am the lead product scientist at PS, and I've been working with PS Tool for over 2 years now. In my role, I work alongside our clients to solve their largest performance problems and optimize mobile apps. I work with companies of all sizes and complexities, and apps across various industries, both for iOS and Android. So enough about myself. Let's talk a bit about us as a team. So who is product science? Product science was built with a mission to make performance engineering accessible to everybody. From this mission, the tool was created, which is a mobile app tracing tool that allows engineers of all levels to easily and intuitively analyze their apps. Our release of self-serve specifically allows users to go through all the steps of analysis completely independently. Now, in terms of who we are, the core of our incredible team is made of engineers from various backgrounds, ex-Snapchat, ex-JetBrains, ex-Robinhood, and many others amazing teams. So we've all experienced performance issues with the products that we've developed. And we've seen the impact of performance on the economic metrics of those products, starting from immediate change in user experience once performance issue is resolved, such as engagement, retention, time spent in the app, and all the way through the impact on business metrics such as revenue, subscriptions, average bill, etc. So we know from firsthand that efficient performance, fast apps providing smooth and seamless user experience is often just as important economically for mobile apps as adding new features. And this is why large companies have dedicated performance engineering teams and spend millions of dollars each year to save those milliseconds of users' wait time. That is because those milliseconds of wait time actually saves them tens of millions of dollars. So we all agree that performance is important. Now, before we dive into the solution that I'll show you today, let's talk a bit more about the problem, what we're solving here and why. So as I said, we can all agree that working on performance is important, but it's also extremely hard. If you've ever done it, you can probably confirm that performance work often tends to be isolated from the rest of product development. Most of the tools, many of the tools at least available on the market, are designed to notify you about delays, but not really pinpoint the root cause. So then to actually figure out what is happening and why something in your app is slow, to backtrack and resolve the root cause of that, it requires a lot of attention, a lot of tedious work, often testing hypotheses, using multiple tools, failing in one hypothesis, starting again, diving in legacy code. And it's kind of painful even to talk about it, not just to do this yourself. So that's why PS Tool was created. And as I said it previously, it is aimed to make performance engineering easy and intuitive. So previously, our integration process was more collaborative and required multiple steps. And with the release of self-serve, it allows us to open PS Tool to a much broader audience, to all of you. And this brings us one huge step closer to our original goal of making performance engineering accessible to everybody. So this is why I'm so happy to discuss this topic with you today. Now, enough with the general introduction. prior to jumping into the tool, I want to briefly share that everything that I am about to show to you today is publicly available right now at no cost. So in today's demo, I'll walk you through not just the tool usage itself. Maybe if you joined our previous demos, you already saw kind of the idea, but this time you will be able to reproduce every step that I'm sharing, from browsing our demo example to instrumenting and eventually analyzing your own app. So I strongly encourage you to follow along the steps. And we're going to shift gears now and take us to our website to kick off, as it is a perfect place to learn about key features of PS2 before we see it in action. Additionally, if you are an Android engineer working on Java or Kotlin app built with Gradle, you can already integrate PS2 with your own app and begin using it. So if your app is different from that, as I just listed, but you're interested in trying out PS2, also reach out to us. You can do this in chat or just DM me in LinkedIn or in Zoom, wherever. So as I said, switching gears, taking us to the website to learn about our exciting features before we jump into the tool itself. So here we are at productscience.ai. Gabi, if you can drop the link to the page in the chat of LinkedIn and Zoom, that would be amazing. So feel free to join me along, especially if you have multiple screens in front of you. So yeah, productscience.ai. As I promised, we're going to speak a little bit about key tool features and explain how they solve the problem of understanding how your code really executes and understanding the core reasons for any performance degradation, delay, or just anything that you would like to speed up. So first thing first, PS2 is a tracing tool. It allows you to make a recording of what's happening in your code when you're using your app. The key here really is in what you record and how you can analyze it. Now, PS2 consists of two high-level components. There is a plugin that instruments your app, and there is a web tool used for visualization and analysis of the data that you capture on traces. Now, the plugin allows for automatic instrumentation. That's the first feature listed here. I'll talk a bit more about it because it's really important and amazing. And that is the heart of our technology. Now, if you've used tracing tools before and done manual instrumentation, you know how much continuous effort maintaining this instrumentation takes. And if you're familiar with profilers, you'd probably know that they often show too much data, and it is hard to make sense of it, to navigate it, as well as it adds up performance overhead that makes recorded experience far from the real user's experience. So our plugin does automatic instrumentation that doesn't require any additional effort to maintain it as your code evolves, massively simplifying the instrumentation process, especially on long term. And it also filters out all the non-essential data, not causing any performance overhead or anything like this. So when looking into the data, we'll also understand a little bit more about the plugin and what data is captured and how it can be used. Now, the two other key features, I'd put them under the visualization umbrella. I'll cover them very briefly because we will have plenty of time to see them in action very shortly. So these are trace video synchronization, code UX synchronization is written here, and critical path analysis. Now, code UX synchronization allows you to record user experience on the device and synchronize that screen recording with what is happening on the code level. And this allows to clearly see how your code reflects in the UI. Isn't it great? Yeah, no more guesswork of like when user actually see results of the code, of something happening in the code. Now, critical path allows you to clearly see dependencies between functions across all threads. with this feature, you are able to separate any various async processes from one another and pinpoint any performance bottlenecks with ease. So no matter how small the function that causes that performance issue is, you will see that and you will be able to understand that this is the core of any performance issue. During the demo, I'll show you critical paths on an example, very explicit example, where you'll be able to see what it actually means and how valuable, in fact, it is. Now, without further ado, let's jump into the tool. I'm going to walk you through the usage and functionality of PS2 and its self-serve version via a live demo example. So that is a trace of an open source app, which is publicly available on our webpage. Our live demo is an interactive guided tour that provides descriptions of every step on the analysis process, starting from the integration and all the way through the end of the analysis. Now, if you're following along, to get to the demo, just click on See It in Action button on top of the screen here, or follow the link in the chat. That's good? Okay, so to the demo. We have overview of the, as I said, guided tour over here. If you click Take a Tour, or if the first step already pops up in front of you, you'll be able to see, well, the guide itself and follow along the steps. So, as I mentioned, yeah, completely interactive, the demo was developed in such a way that you can go back to any step at any point in your initial walkthrough of the demo. And also, if you are refreshing your memory after this demo we have today, you can always just pick the step you want to get back to. You can also, at any point of the demo, at any step, you can collapse the demo. You can browse around the tool, do anything you want, click anywhere you want, and then just click Continue Tour button over here. And you'll be back on track. You'll be able to continue with the demo part. So in this demo, in this live demo example, we will have two main parts. The first one will be an overview of our UI, and basically to make you familiar with the UI and key features of the tool. Now, the second one, we will pay more attention to the exemplary trace itself and try to make sense out of it, so that we'll see what kinds of optimization opportunities can be captured with PS2. So yeah, as I said, don't hesitate to collapse it, play around with it at any point, investigate. This is your playground, so enjoy. Now, diving into the first part, into the UI overview. First couple steps here will cover kind of the center area of the UI that we have here: aggregation view, main timeline, and threads. I'll collapse it now. So basically, in the main area, you have here the trace recorded. That is everything that was happening in your code while you were recording the trace. Now, if you scroll down and up, you will navigate through all the threads that were involved in the code execution while the app was running and while you were recording the trace file. So you have all the threads, you have like condensed view of everything that was happening in the app here on top. You have main timeline on top, that is time from when you started recording till when you finished it. And you can also zoom in to any point in time on any thread to see what actually see closely what was happening in your code. So to zoom in and out, you can either use pinch zoom if you're using touchpad. If not, on your keyboard, you can always use W, A, S, and D buttons, like in any, say, computer game, to navigate. So W to zoom in closer, S to zoom out. And if you zoom closer, you would see these rectangles. You'll see the flame chart diagram. Each rectangle will correspond to a single function. And from the view of it, you can just capture the name and the class and actually pinpoint what was happening in which thread at what moment of time and find that same place in your code. So let's move on. Another important part of the UI and the analysis process is about the video and trace video synchronization. So as I said before, trace is synchronized with the user experience. And at the same time, when I start trace recording, I also start capturing the screen. And that video gets uploaded to our tool. We can play the video here. You can see what was happening, what user was experiencing when recording this trace. And you see that it's a podcast app. I just simply clicked on one of the podcasts and detailed information about it appeared on the screen. So I can see it on the video, but also there is this time indicator that moves along the timeline. And if I just hover over it and click on it, move it around, I would be able to find any UI change and see what was happening in the code in the meanwhile. So that code video synchronization is as close as up to 1 frame. Really pretty cool to see exactly how your code reflects in the UI. So covered the video. One more quick thing, which is, I'd say, as important as navigating through the video when you're trying to find any point on a trace file. Besides navigating from user experience, you can also always use search. So if you're looking for any particular method, for any particular function executing anywhere, you can always just put it in search and all the results would be highlighted. Okay. And with that, we can get to the critical path that I promised to talk about. Now, we have here, if you click on any of the methods, right here, as you see on step 8 of the demo, or if you just zoom into this area, you can click on a method. The one selected here is an onSuccess method from online feed view activity class. I won't be going over each of the methods we cover in details, but like when you're working with the app, it's actually important to see that you can find this particular method in your code base and do any changes, do any fixes pretty much instantly because you know where to find it and what was actually going on. So if I click on this method, what I would see here is in details panel, I see in which thread it was running. In this case, it's the main thread, always on top. I would see when it started, how long it lasted, sometimes additional details about them. But besides having information about the method itself and the call stack and how synchronously it was like called from the ones above it, you can also zoom out. And if you zoom out, you would see this yellow line, the critical path. You can also see it here connected in details panel. So the idea behind the critical path is that it captures everything that triggered the function that you clicked on. So not only what called it directly from its own stack, but if it was triggered by something asynchronously from a different thread, you have this yellow connection over here. You can follow along it, and you would see that our onSuccess of feed view activity was called from something much smaller in this stack. And you'll see, for example, feed view activity parse feed. So you know how the process ran across multiple threads, and you can follow it along all the way, backtrack it all the way to the creation of this activity and eventually to the point where user tapped on the button. That's noticeable both with video and with the function names. So for anything you click on, you can see what was exactly the process that led to that function execution, and you can easily also split it out from anything that was happening in parallel but unrelated to your process. Hope that makes it clear about execution, about critical path, and we we will cover it in more details in the second part of the demo when analyzing particular execution paths and finding insights within it. But basically, you click on something, you understand what led to execution of that thing. And once you know how it really executed, you can assess whether it was efficient or not. So that's the whole point of this intuitive analysis. So you can read about critical path over here. And the last, but not least bit of this part of the demo to conclude the UI overview is trace annotations. Basically, anytime you're looking on the trace file, maybe you want to highlight any points to make a note of where something is happening in the UI, or maybe where a certain method stops or begins executing. So you can always drop a flag. It's described here in step number 10, but you can also just hover over timeline, drop a flag here. You can annotate it, leave any comment there. Nobody else will see it. As I said, it's your sandbox, playground. Enjoy playing around with the tool. Click on anything you want. So for convenience, I'll just delete the ones that I just added. But yeah, you can always leave flags to annotate anything that captured your attention. So in this particular example, the flag that I put was at the exact frame where feed detailed information in text about the podcast was shown. Now, if you don't want to always do these annotations by hand, or you want to capture like any particular method to be kind of highlighted on every trace that you record, you can also do code level annotations. In this particular case, again, what we've chosen to annotate was the place where feed was ready, feed activity on success. And it's a pretty cool thing that leads us to the last bit of UI that we're going to cover today, is that you can also measure the distance between any 2 points. Here, there is a hint about it. Just press Shift and move your cursor. I put my cursor here where feed was ready and highlighted by automatic red flag over here. Press Shift, measure. And this way, I can see that there is about 88 milliseconds time between the moment when from the code we think that feed is ready and where this actually appears on the screen. So you can capture any delays that happen even after everything is ready that affect user experience. So that is pretty much it. And that concludes. So you can always get back and see tips on how to measure and how to annotate your file. And that concludes our UI overview part. Now let's quickly go over this trace file and see what actually happened in it and what could be potentially optimized. Heads up, this app that we analyzed today is fairly simple and straightforward. There is not so much happening in parallel, not so much going on. But even here, we will see how you can separate processes happening in parallel. You will see how you can assess the execution path, tell a story, and find any optimization opportunities around it. So the next couple of steps, I'll just skip for convenience and time-saving purposes. However, you can always annotate your trace file based just on the video. You can assign those reactions, those UI changes in your app to the code, so that further on, when you're analyzing your trace, here, if you click on this gray reaction, the slice would be selected and the path would be highlighted. So when working for a longer time with the same trace, this is a really convenient way of annotation. Now, as promised, let's get to the actual trace analysis. So methodologically, again, when tackling any user flow, any page loading, any feature loading, the approach that I always recommend to take is to start with user experience, because that is ultimately what matters. Yeah, this is what we want to improve and to speed up. So for that, I would recommend to start with the video and find for any last step in your page load. In this case, we've chosen this image on the background popping up on the screen. So you can always find the frame and click on that last frame to see what led to the UI update that we were just finding. So with time indicator, I found that one single frame. If I zoom in here, you'll see that this is actually one single frame. That's how precise it is. Click on that frame, and execution path will reveal explaining what led to that frame. Let's briefly go over before before finding optimization opportunities here, before like saying what to fix, let's actually understand what's going on. Yeah. So here the user taps on the podcast. We can see it on the video, and we can see it from the function name. Activity gets created for this online feed view. We have a bunch of something gets scheduled a parallel thread. We see a network request. We see its URL. We can understand what's happening there. We see more methods, kind of parsing the previous request, scheduling another one. Feel free to zoom in to study them in details. And those are the methods that can always be pinpointed in your code base. We see another network request loading the feed itself. I'll zoom out a bit. Then it schedules something to execute in the main thread around here, parse activity, parse feed. From parse feed, we'll trigger another, we'll actually trigger a parse feed function happening in parallel. That leads us to the UI update for the feed appearing on the screen. And once feed is ready, from main thread, we also schedule another network request that is loading the image that appears on the final as a final UI update here. So image is loaded, image is decoded, and finally it appears. Well, decoded really. You can see that it's decoded over here, and it finally appears in the main thread. Now, again, let me zoom out. So user taps on the button. There is a sequence of network requests, a UI, some dependency on main thread, parsing the feed over here, showing the feed on the screen. And only from the moment when we showed the feed, we start loading the image. I promised to tell you how you can separate processes happening in parallel. Again, simple app, but here is an example. We have two images loading here. They are almost identical. They actually look the same, but they are loaded separately. And you can see how this image loading with this preview with URL is a part of our execution path for this particular frame that we clicked on. And then the other one, identical image, is loaded in parallel and decoded on its own here. So if I click on this decoding, I'll see a separate execution path. Very similar, but going through a different network request. So in more complex scenarios, you can always separate the processes and actually understand how they interfere with each other, if they create any bottlenecks, if there is queue in maybe main thread because it was overloaded by something unrelated. Besides looking into interference of parallel processes, you can also always assess the path itself, assess whether any of the requests could be scheduled earlier where all the dependencies are necessary. For example, most of the cases, dependency on the main thread and any view update is unnecessary to send the next network request. That's about it. That's really everything you need to do. You record a trace, you find the UI change, you click on a method, and then you see what caused it execute when and where it ran, and if the process leading to it could be optimized on its own, if it's delayed by anything else, and if like maybe any intermediate step of it could be simplified, anything like image loading could be happening in parallel with UI update. So that's pretty much it. And I hope like with this, seeing this, you're as excited as I am to like use the tool to try it with your own app. So don't forget to sign up. There is a sign up button here on top of the screen that would lead you to a sign up page. Just create your account. And if you have Android, Java, Kotlin app built with Gradle, you'll be able to instrument your app straight away. Otherwise, let us know. Let's talk. We're gradually releasing different versions of the tool to public. If you have Java, Kotlin, and Gradle app, you'll get to these build instructions. Pretty straightforward. You will need to add a couple lines of code. I'm not an engineer myself. I've never worked as a mobile engineer, but pretty straightforward instructions. I was able within these years to find insights in many apps, but also for the open source apps that we tested our tool on, I was able to reproduce these steps. Just copy a couple lines of code into your build.gradle file, turn on product science plugin, you'll be issued credentials over here, and that's it. Just build your app, and with that, you'll be able to build instrumented app, and with that, record traces, record video, analyze them in the tool. That's pretty much it. I think we are ready to wrap it up. Let me pull in the last slide here. Thank you very much for your attention. Let's do 1 minute for questions.